All right, I think we'll go ahead and get started. Welcome everyone to this webinar, and thank you for joining us today. The webinar is being simultaneously translated, interpreted into Spanish, but this means that everyone needs to select their preferred language. To do this, please go to the More button at the bottom of your screen, select Interpretation, and then select either English or Spanish. As we've marketed this my name is Judy Zakreski, and I am the Senior Vice President for Global Operations and Solutions at the International Code Council. I work with governments and stakeholders around the world to improve their building safety regulatory ecosystems, from the development of right-sized enforceable building codes to ensuring compliance with building safety regulations by building capacity, both institutional and personnel capacity. ICC works globally with specialists in place to address the particular building safety needs in Latin America and the Caribbean, as well as in the Middle East. This is the first webinar of its kind, motivated by the recent and tragic earthquakes in Venezuela, but certainly not limited to this situation, particularly as the world is experiencing increasingly frequent and severe hazards that require the assessment of the safety of buildings in the immediate aftermath. ICC has been exploring in recent months how our When Disaster Strikes Evaluator training program, which was initially developed for use by US jurisdictions, can best be leveraged and customized to help around the world to provide contextually appropriate, immediately implementable solutions to jurisdictions globally. And in working with Stephen Forneris, an architect who splits his time between New York and Guayaquil, we thought that it would be a useful first step to provide this free general introduction to the concepts of our program and to begin to assess interest in partnering with groups across Latin America and other regions around the world to customize it to your particular needs. We're thrilled to have you with us. And again, I'd like to introduce Stephen to provide a little more context for his motivation to work with ICC on this project. And after Stephen, you'll hear from my colleague, Jose Ruig, the Regional Director for Latin America and the Caribbean for ICC, followed by the main reason you're all here, to hear from Bill Bracken, ICC's expert in this area and the developer of the When Disaster Strikes programs. Thank you again, everyone, for taking the time to join us today. And with that, I'm happy to turn the presentation over to Stephen Forneris. Stephen?
Great. Thank you, Judy. And really thank you, not only Judy, but Jose and William and Mark Johnson at ICC for putting this together and believing in us that we could do something like this and expose this to everyone. Just a little bit of background and context. I'm a managing principal at Perkins Eastman Architects, a private architecture firm, large-scale architecture firm working in the United States, but I manage our office in Guayaquil, Ecuador, where we've had a presence now for almost 20 years. As Judy said, I split my time between the United States and Guayaquil, Ecuador. And I've been involved there for now the past 30 years. I'm a licensed architect in Ecuador, practicing in Ecuador, Colombia, Peru, and I'm also a licensed architect in the United States. We share a lot of challenges between between different countries, different parts of the world, and going back and forth between the United States and South America has lighted a lot of things for me as a professional. Building codes and standards are at the top of that. When you work in New York, you see what the building code and standard is, then you go to Colombia or you go to Ecuador and you begin to ask, what are we doing here? And in many South American countries, from wherever I've been, many Latin American countries where I've been working, we see a lot of building codes and standard systems that are being formed and adopted and being adapted from different places in the world. However, pulling these together, there's oftentimes a lot of overlap, and I'm sure that many of you see this in terms of these overlapping systems. My contact with South America is very personal. like many of you. My daughter lives in Ecuador. She's 30 years old now and been living there for years. And I'm deeply connected to the region and the people, just as all of you are, and deeply concerned about disasters and earthquakes in the area. In the core of the problem comes from in 2016, there was an earthquake, a 7.8 earthquake in Ecuador, resulting in about 650 deaths. And like a lot of local professionals, went around and tried to see what we could do. We did inspections of buildings, brought some engineers and architects from the United States, teamed up with engineers and architects from Ecuador. And after 4 days, we did only 12 inspections of buildings. We couldn't get the reports done until about a month later. We didn't have a comprehensive way of really looking at buildings correctly. This got me thinking about, well, how do we do this in other parts of the world? And I was put in touch with a lot of groups in the United States on how we do these type of evaluation systems, and to see if there might be something that we could do for similar in South America. That's where I bumped into the program at ICC. There are a lot of programs in the United States. Many of them are very state-oriented and rely on licensing and the state, but ICC is more of a global view. And this is a little bit what we're going to be getting an example of today through Bill's course. And I want to mention that ICC is very open about developing this and putting this stuff together for us in Latin America. When the recent earthquake occurred in Venezuela, I realized from speaking to a lot of professionals that you're working with a lot of the same basic core texts that we have in manuals in the United States, but they're not in Spanish. And ICC is beginning to work with us about putting these things into Spanish. So there's a great need in our region for this type of training. Architects and engineers can be the first wave of individuals that go out and help the community understand that you can feel better about going to the building, understand how when a building is safe, when it isn't safe. And it's something that we can offer our communities that is incredibly valuable. I hope that all of you will be inspired by this. Please reach out to Jose. He'll be pulling us all together and connect with him. Become a member, as I am a member of ICC, volunteer member. You can become a volunteer member too and help affect change. And thank you again, Judy, William, and Mark, and everyone and Jose and everyone at ICC for putting this together. Jose, why don't you kick us off on your side?
All right, Stephen, thank you for that intro. And thank you, everybody. Good morning. Welcome, everybody. I'm excited to see so many people from so many places here. So thank you for joining for today's webinar, When Disasters Strike. Just to make sure, if you're listening in English, you can select Spanish at the bottom. You go to More, and you can go to Interpretation, and there's two channels, so you can actually listen in your language. I will stay in English because we have interpretation. So my name is Jose Roy, and I'm actually serving as the Regional Director for Latin America and the Caribbean for the International Code Council. I'm excited to be here. I think this is a much needed webinar that we are sharing with you all today. For those who may be less familiar with the ICC, we are the global leader in developing model building codes, standards, training, and solutions that help create safe, resilient, and sustainable communities. Our mission is to provide that information, the tools, the resources that our members rely on, that building safety professionals turn to, and the public actually trust. So we are known as a leader on that arena. We have a commitment to the global community, and now in my position, to Latin America and the Caribbean. At ICC, we are deeply committed to supporting governments, building officials, engineers, architects, and all the stakeholders throughout Latin America and the Caribbean. A key part of that commitment is ensuring that building safety resources, training, educational programs are accessible to Spanish-speaking professionals, and they are applicable to jurisdictions beyond the United States. So we do recognize that while communities may face different hazards, they may have a different regulatory system, they may have different building practices, different building materials. One thing that we do share is a common need for practical tools that help strengthen resilience before and after the disaster occur. So that's something that we share because we see this happening everywhere, whether it's an earthquake, a flood, hurricanes. I mean, this is something that we are dealing with, and it's important for us to share that common knowledge. So one important initiative supporting this effort is ICC's When Disaster Strikes program. This program provides resources, it provides training, it provides guidance to help these communities prepare for, respond to, and recover from disaster events. The program promotes one thing that you'll see today is effective post-disaster building safety evaluations, because it's a challenge once you get a situation like this one to go back and evaluate all these buildings, and also supports the local authorities in making those informed decisions that protect building safety while you have to accelerate the recovery of the area. So I'm also pleased to share that ICC will be in process of preparing an international version of the post-disaster building safety evaluation training, and that we developed specifically for jurisdiction outside the United States. This training will provide practical methodologies and best practices that can be adapted to local needs, helping professionals assess building safety and support their communities during post-disaster response and recovery efforts. As part of the ICC ongoing commitment to the region, we will be working with the Catholic University of Ecuador and other regional partners to develop Spanish language versions of the WDS program and related post-disaster building safety resources. And our goal in this one is to make sure that these tools are more accessible and relevant for professionals and authorities throughout Latin America, while we ensure they reflect the realities and the needs for these jurisdictions outside the United States. So these efforts represent an important step toward building local capacity, towards strengthening the disaster preparedness and supporting safer recovery process across the region. Now, I don't want to take more time. I really want to make sure that we get to the meat of the program. So I want to actually introduce William Bracken, which will be sharing with us the presentation. And with that, it's my pleasure to introduce him. And he's going to share some valuable insights and practical experience on his important topic. So thank you all for joining us today, and I hope you find this session informative and beneficial. Bill? You're muted.
My apologies. So thank you for that, Jose. I'd also like to recognize and thank Stephen and Judy, and I'm going to build on the comments that they have made. My goal here this morning, and I appreciate the opportunity to share this information, but my goal is to give you an understanding of what the When Disaster Strikes program is. This is a program that was built by the International Code Council. And it is a program made up of training courses, training materials, resource materials, and other items intended to support jurisdictions when dealing with both the response and the recovery from disasters. And so, excuse me, working with Stephen, Stephen identified the need for the post-disaster building safety evaluation course, identified the need for that course in Central and South America, as well as throughout the Caribbean, and approached us. And so that is what we have done. We have actually created an international version of one of the courses, perhaps the foundational course, which is the Evaluating Buildings After a Disaster. What I'm going to do in the presentation, which I'll put up on the screen here in just a second, is to walk you through that training. I'm not going to deliver the training, but what I am going to do is to walk you through how it's put together, what it focuses on, the various modules, and the key elements. There are some items that will be further modified and developed to make it easier to deploy throughout other parts of the world. Now, I'll talk about that as we get into it. So let me go ahead and bring up the presentation. So hopefully everyone can see my slide or my screen at this point. And as Judy and Stephen were saying at the start of this, if you have any questions, there will be plenty of opportunities to put them into the chat box to have those addressed, and certainly we'll leave time. I will also pause in between the various modules to see if we have any questions or if there's anything that perhaps needs further clarification on. So the class that we will talk about today is, and this will serve as, the presentation will serve as an introduction to that class. And the class is the When Disaster Strikes Evaluator. And really what the When Disaster Strikes Evaluator is the performing of post-disaster building safety evaluations. So When Disaster Strikes Evaluator training, which is the focus of this class, it's about when and how to perform post-disaster building safety evaluations. And I recognize that's a very large title. Basically, in essence, what we're talking about is in the wake of a disaster, whatever type of disaster you're dealing with, this class will help you to train individuals who can go out into the community, look at the damaged buildings and infrastructure, determine if they have been affected, and if they have been affected, to what extent. Specifically, are the buildings and those portions of the infrastructure still habitable, or are there limitations, or worse yet, are they just too unsafe for the public to then enter? That's really the focus of this particular training element. The objectives of this training are to view and review the various types of phases and disasters and the role of the post-disaster building safety evaluator. It's also to review the importance of performing post-disaster building safety evaluations both rapidly and consistently, rapidly being the key component there. The training introduces and discusses post-disaster building safety evaluations, when and how to perform them. It introduces and discusses operational environments and disaster-related hazards, both to the evaluator and to the public. And then finally, it talks about training and credentialing and other training opportunities that exist and will be rolled out. The actual organization of the training is by module or by section. There are two types of sections. So the training begins with foundational modules, or if you will, the basis upon which the training then builds. And you see each of those bulleted through, and we will go through each of these in today's presentation. And then the second type of module is an operational module. And when I say operational, what I mean there is, how do we actually do this? And what type of conditions, hazards, situations can we encounter when out there and doing these evaluations? Finally, it gets into the actual processes, and it provides a vehicle for attendees or students to practice these evaluations through case studies, examples, practice examples, and so forth. And then finally, the ultimate goal of these evaluations are the placards or the signage that we will be posting on the buildings. And it gets into the types of signage or placarding and the rules upon which those placards are affixed to the buildings. So as I said, the goals and objectives overarching are when these post-disaster evaluations are performed, when they are successfully executed, they will help to keep our citizens from entering potentially unsafe structures or buildings, while also minimizing any displacement or permanent displacement. And while those two concepts may sound to be in contrast, they are not. And the training is one to educate individuals on how to perform these evaluations, but also how to determine when a building truly cannot be occupied or when it has damage that will just simply constitute restrictions on its use. By identifying and refining those two, we can help to minimize displacement of our citizens. So the first module of the training, as I said, there are foundational modules, and that's what the training goes through first. But the first of the foundational modules is this one. It's module 1, disaster events and examples. And so the way the class is put together, it starts with the big picture. It starts with an overview of just simply defining what is a disaster. This particular module highlights 4 types of disasters that will then be used and carried through the balance of the training. Now, some of us might look at the types of disasters and say, well, my community is not going to experience one of these types of disasters, or my community has another disaster type that we need to be aware of and possibly train for. That's the beauty of this program. And as Stephen was saying, it is very easily tailored to local, regional, territorial, governmental needs. So this program is very adaptable. It can be expanded, it can be contracted, it can be focused in on particular areas and regions. But the international training course highlights these 4 types of disasters. And so the training itself begins with these disaster types. It provides illustrations and examples of these types of disasters. The training then goes into how these disasters impact buildings, how to evaluate the extent of that impact, and so forth. So I'll walk you through the training. Now, many of the slides, this training course is anywhere from 6 to 8 hours in length. We're not going to go through all 6 to 8 hours of training. It's been consolidated down to about 90 minutes or so of just the highlights of the training itself here for awareness and educational purposes. So as I said, the first module introduces disasters and disaster types, and it gives examples. It also, you're going to see on the next slide, it provides video footage of actual disasters to help set a frame of reference for the participant. On this particular slide, you can see 3 examples. There's the June 2026 Venezuela earthquake, the more recent one. It was actually twin earthquakes, the first one being a 7.2, which was then immediately followed by a 7.5. Those are devastating events, devastating types of earthquakes. But even further, there were examples of the 2016 Ecuador earthquakes, a 7.8 magnitude earthquake. And then a little bit further back, the February 2010 Chile earthquake. That was a magnitude 8.8, an extremely large event. So we start with examples, and again, this is an area where the examples can be made country-specific or region-specific. And then we introduce, and throughout the training, there will be videos, photographs, images, and discussions of the disasters, the types of buildings, and then how those disasters impact buildings. This first one is some video footage. It's a compilation of videos that were put together based on an earthquake that occurred in Taiwan. And so you'll see some footage and possibly hear the sound on some of these. Not all of them have sound, but just to play it, these video footages are generally about 60 seconds or so in length. So as I said, this is a compilation of footage, but both this image here and this one, shows basically individuals on a bridge. But the next series of images, you're going to see the outcome and some of the buildings that were impacted, such as the one you see on the slide right now. So that was earthquakes, and that's the format you're going to see for each of the 4 types of disasters in this version. The next one talks about the disaster type it talks about is flooding. And so some examples of flooding were the 2009, 2010, 2011 floods that occurred in El Salvador. Additionally, there were 2010, 13, 14, 15, and 19 flooding events in Bolivia. And then, of course, 2006, 2008, and then significant flooding in 2016 in Ecuador. This next footage, again, to illustrate the impacts of flooding, this is actually a compilation of flooding. This was coastal flooding related to a hurricane typhoon type of event. This was in the US. And what you're going to see is about 60 seconds again on the footage, but you'll see the impact of storm surge and coastal flooding as it builds. What I'll ask you to do is, as this plays out, keep an eye on the building in the foreground, the reddish shaped shaded building, and see how it fares as this water continues to build and the intensity increases. So again, the purpose of the footage is to help for those that have never experienced these types of disasters, or just to kind of ground where it is that we are. That's the intent of the footage. The third type of disaster that the training focuses on are high wind events. And so high wind events are actually broken into 2 categories or subcategories. The first subcategory being tornadoes. Some examples of tornadoes would be the April 1993 Buenos Aires tornado outbreak. That was an event that in 1993 resulted in 100 independent tornadoes affecting that region. Another example was in 2009. The tornado outbreak in Santa Catarina, and forgive me if I mispronounce anything, but nonetheless, in that one particular tornado event, it resulted in destruction of more than 80% of the residences in that community. So tornadoes are not limited. They are highly specific and specific to areas and regions, but certainly worth becoming familiar with. For those unfamiliar with tornadoes, and for those who have never seen the significance of the impact a tornado can have, this is some footage. This was inside the US. This was Lincoln, Nebraska, so in about the center of the continental US, North America. This is a tornado. This is some footage, again, about 60 seconds or so. And what you're going to see is you're going to see the tornado enter from the left-hand side of the screen, and it will move from left to right. In the background, in the foreground, are automobiles in a parking lot. And then in the background is a multi-story concrete, cast-in-place concrete building that is quite literally obliterated by the disaster, by the tornado. So let me play the clip for you. So again, for those unfamiliar with tornadoes, clearly a disastrous event. Tornadoes are very small, condensed areas, but they also have very powerful, intense winds associated with them, as you can see there. So in that particular case, that was a very large concrete facility that the tornado just simply leveled. And then the second subcategory on the high wind events are hurricanes. And so two examples that we highlight here are the 2007 Hurricane Felix. That was a Category 5, or the largest of this type of event, making landfall in Nicaragua. And then more recently, the 2020 hurricanes Eta and Iota, two consecutive major hurricanes that struck Nicaragua, Honduras, and Guatemala, all of them having significant impact. As you've seen with some of the others, this is just some footage of a hurricane event. It shows the impact of the winds. You can see from this video footage, I'll go ahead and start it, but you can see the intensity of the winds, and you can see the impact those winds take on buildings. It's the building we're seeing here in the slide. You can see as the winds continue on, additional segments of the roof are taken off. The perimeter concrete block wall, if you keep an eye on that, you'll notice how it just simply gets blown in. So the intensity of the winds in hurricanes are significant. And once they open up a building, they cause damage and open the building, that's when the building becomes susceptible and buildings quite literally just come apart. And then the last type of disaster that the training focuses on are wildfires. And so two examples of wildfires would be the 2021 wildfires in Argentina that by the time those fires were extinguished had destroyed hundreds of homes. And then most recently, the 2026 wildfires in Chile and Argentina that destroyed nearly 45,000 hectares of land and more than 1,000 homes. So some footage associated with those fires. This came out of Northern California. And the footage here is from some fire crews that were in the fire. They were actually traveling from one spot to another when the fire changed direction, swept over, and they found themselves engulfed in the actual flames. The firemen making this video, this is from a dash camera, but the firemen successfully made it out but this gives you some idea of the intensity of those types of disasters. And then, of course, afterwards, most of the buildings were significantly or completely destroyed. And then, of course, as I said, at the end of each module, there's always the opportunity to open up to provide further discussion, take any questions, provide any answers, and so forth. So these are we will not see it as we move through the balance of this presentation, but it's worth knowing that at the end of each of the modules, there are opportunities to then further discuss items. The second module, having introduced the disasters and the disaster types, the second module then gets into damage modes, or specifically, what are the various types of damage that these disasters can cause to buildings. Focusing on the 4 different types of disasters and keeping in mind that each of these disasters will have different impacts on buildings and the built environment. And so it's worth talking about how each of these disasters impact buildings, how they can cause damage, because that then provides a frame of reference for individuals going into communities after a disaster. They will already have some idea of what type of damage to look for and how to anticipate the damage that they will be evaluating. The first type of damage and the first disaster that we'll talk about is earthquakes. The training talks about how it is that earthquakes occur, and then how that disaster, or in this particular case, earthquakes, impact buildings. So as you can see on the screen here, earthquakes are a seismic event. And what a seismic event is, it is caused by a rapid release of energy in the Earth's crust, causing and allowing the earth and the rock below the surface to shift. Or in other words, all of the plates on the Earth's surface are constantly moving. And so when 2 plates become fused or stuck, the energy continues to build. And so as those plates continue to move, the energy associated with that movement will eventually overcome the friction force holding those plates together. The plates then release, and that is a release of energy. That energy then shakes the ground in multiple directions, both forward, backward, side to side, as well as up and down. The ground is moving, and so naturally the buildings sitting on the ground are going to then be moving as a result of the ground movement. So all of that is explained in much greater detail, and in a way so that the participants will be able to take that and in later modules see how to look for that type of damage. The second type of disaster was flooding. And so with flooding, similar to what we just saw with earthquakes, what is a flooding event? How does it occur? And then more specifically, how does flooding impact or damage buildings? Well, in the case of flooding, it can cause damage to a building in one of 3 ways. It can saturate the ground and possibly building components. And by saturating the ground and the building components, it softens them. That can sometimes lead to settlement or partial collapse of aged, deteriorated, or weakened building components. The second method that flooding causes damage to buildings is through hydrostatic force. And what hydrostatic force is, it's that buoyant force, or that force that basically causes ships to float. In other words, anytime you displace water, that displacement can cause the building to lift or shift, thereby damaging the building. And then finally, The third way that flooding can damage or impact a building is through hydrodynamic forces. And the hydrodynamic forces are waves and surging water. And that's more or less what we saw in that flooding video when you saw the waters coming in. They lifted the building up, they carried the building downstream, and then eventually just destroyed the building. So the training gets into the three ways that the flooding and the flood waters can impact and damage a building. The fourth type of disaster and damage caused by disasters is high wind. And as I said earlier, we break it into two categories: tornadoes and hurricanes or typhoons. But really, whether it's a tornado or it's a hurricane or a typhoon, wind impacts a building in really three ways. The wind flowing around and over a building will put pressure on the outside of that building, and that pressure translates into loads. So we want to make sure that the building is capable of supporting and resisting those loads. But the other methods or the other ways in which wind loads can impact buildings is by windborne debris, or picking up items, carrying them downwind, and creating openings in buildings downwind, breaking windows, breaking doors. The reason that that's damaging, aside from the broken windows or the broken doors, is once that opening is created in the building, the wind and the wind pressure can get into that building, pressurize the inside of that building. And when that internal pressurization combines with the external pressurization, that's when buildings start coming apart. The last disaster type is fire. And so here what we do is we talk about how fire and heat or thermal events impact buildings. And as you can see on this slide, the fire itself and the heat from that fire, please keep in mind, it's not necessarily the flame that causes the damage. The flame is merely a byproduct. It's the heat or the heat energy that causes the damage. So the heat energy can change, will change material properties. It will cause wood to burn. It will cause steel to elongate, soften, and deform. It can cause concrete to become brittle and crack. So with fire, the focus is on the members, the materials, what the heat energy has done to those components. And so, as I've mentioned on the previous slides, with the fire slide, the training goes into much greater detail about the effects of fire and its impact on buildings, and how to look at buildings that have been affected by fire, where to look at those buildings to determine if that building has been impacted. If it has been impacted, to what extent. So I think you can see we start off with a discussion around disasters. Then we go into a discussion around how those disasters and the forces, the effects of those disasters have on buildings and the built environment. Next, we go into the fundamental structural and life safety components that we need to know when evaluating these buildings. So to say that another way, this next module looks at the building how the buildings are put together, and how it is that we're actually going to determine if a building has been impacted by a disaster, and if so, to what extent. So this module focuses on the types of structural systems that exist. It focuses on determining, right, how the evaluator is able to determine structural safety and how the evaluator is able to determine life safety. Because at the end of the day, all of this training comes down to making sure that the evaluator is looking at these buildings and determining whether that building has basic structural safety and basic life safety or fire egress. So we'll talk about the significance of each of those as we go through. But at the core of this training, it all comes down to these two items right here: structural safety and fire egress, which is life safety. So inside of the training, there's a review of structures and structure types. And for the purpose of the training, there are two types of structural systems. All of our buildings employ these two types of structural systems. Some buildings, it's all one or all the other, but the vast majority of our buildings are a combination of these two. And so the two types of structural systems are what we see on the screen here. They are the bearing wall system and the frame system. And so with the bearing wall and the frame system, we go through and we talk about how the bearing wall and the frame receive loads and how they're affected by overloads. So in this particular slide, you can see the bearing wall. The bearing wall is just simply a wall that receives a load from above or from the side. That wall then is to carry that load down to the foundation, where the foundation then resists that load. So as we apply loads to, in this case, a bearing wall, right, we need to understand how those loads travel through it. And then the same thing with the frame. So with the frame, it's all about how the loads travel through that structure or that structure type. So in a frame system, the load gets applied to the floor, and then from the floor, it goes to the beams, and from the beams, it goes to the columns. Ultimately, from the columns, it goes down to the foundation. And so that is our load path. And understanding the load path through the bearing wall or the frame helps us then know what we're looking at, what we need to evaluate, and what parts of the structure we need to determine, have they been affected or damaged by the disaster or not. Part of that process of evaluating the load path or evaluating the structural components is, one, determining the load path. What is the load path that the building relies upon? Once the evaluator determines the load path, then they're able to look at the frame components, the bearing wall components, the connections, and the foundation to determine if there is adequate structural safety. In going through that process, or I should say, when going through that process of examining the load path, you also want to determine the redundancy and the ductility. And so I'll give you an example of that. So the load path is, as we see on the slide here, and the training provides multiple examples for many different types of structures and types of structural systems. For the purpose of this presentation, I'm just using one as an example. But when we get to the load path, here we can see a traditional roof over exterior bearing wall. And so the load path here would start at the top. It would go from the roof. into the bearing walls or the supporting walls, from the bearing wall down to whatever type of foundation system we have, and then ultimately down into the foundation. And so it's the process that the trainer walks the attendees through the process of each of these elements and their connections. How do we identify them? How do we evaluate them in the field? The other part of evaluating structural safety is determining redundancy. And so on this slide, you can see two simple examples. The top example is considered a simple system, meaning it has no redundancy. As you can see in the graphic, it's made up of two columns and one beam. And so to say that it has no redundancy, if it has no redundancy, if I lose one of these elements, then the entire system fails and falls to the ground. And as becomes apparent later in the class, in a simple or a non-redundant system, that's when you get total collapse, the building falls to the ground. And quite honestly, we're not needed, right? Even the basic resident, the layman, can identify when a building has completely collapsed. Really, what the focus is on is, and what we need to evaluate is when a building has redundancy, as we see in the bottom graphic. So in the bottom graphic, we have three columns supporting a continuous beam. Well, it is possible for that building to lose one of those columns, and that beam is still going to remain. That is what we call a redundant system. Now, that does not mean that the building is safe. In fact, it means the building has been damaged. It could be quite severely damaged, but it is still standing. And so that is really the focus of this training, is those buildings that remain standing due to redundancy, that the layman cannot interpret, that we need to be able to then evaluate. And then the final piece of evaluating the load path is ductility, or determining ductility. So when we say ductility, really what we are doing is we're looking at what the structural system is made of and determining if it may have additional strength beyond what we're seeing. Or if you would use an engineering term, it would be additional capacity. Simply put, we have two types of systems. One is ductile and one is brittle. In a ductile system, as you see in the blue portion of this graphic, that's going to be a steel type of system, meaning if I have a structural steel frame, that structural steel frame has a great deal of ductility. It will bend and move and deform before it fails. And so the evaluator is trained on identifying if that system, that structural system, has ductility, if it can continue to bend or move or not, versus a brittle system. A brittle system would be an unreinforced brick masonry structure that has no tensile capacity or no ductility. In other words, in an unreinforced masonry system, it is not going to have much ductility. And so when it is subjected to movement or additional movements, it is subject to total collapse. And so, as I said, the training utilizes video and video footages to provide examples. And so in this video, and it's just, again, about 60 seconds, this is some video footage of an unreinforced masonry building during an earthquake I believe this was during the Mexico earthquake a number of years ago. And so when I launch the video, the camera is going to pan to the right and you will see a multi-story brick building. The video footage is being captured by the people who were evacuated from that building, and they're using their cell phone to capture the footage. And so this serves as an example of a non-redundant, brittle system that cannot handle movement, and you'll see the outcome. You can see the building is shifting. It's moving side to side. So you can see that's an example of a brittle system that does not tolerate movement. So again, I have not included all of the videos. I've included a few here to provide some examples of the modes of training that are employed in this class. So all of that was the structural piece. So as you remember, I said at the start of this particular module, there is structural safety and life safety, or another term for life safety is fire egress. So structural safety is, quite simply, will the building continue to stand? That is key to us determining whether it is safe for the public to be in there. But the second component to all of this is egress, fire egress, life safety. That is quite simply, if something bad happens, if the building catches fire, can the people in that building still get out of the building safely? That is fire egress. So in order for us to tell the public that that building is safe to reoccupy, the building must have structural safety and life safety, or fire egress. And when I say fire egress, it's, as I said, it's all about, can the public exit that building safely in the event of a subsequent disaster or a fire or some desperate need to get out of that building. An example that is used here, this is a multi-story building that you see on the slide. It's actually a 4-story building. This was in a residential area after an earthquake. The structural system is a bearing wall system, and it had a brick veneer on the outside of that bearing wall. As you can see in this image, the brick veneer is peeling off of the building, and it is actually threatening and causing damage to the fire escape. And so while the fire escape was not damaged by the earthquake, the fire escape cannot be used because of the falling brick. So because that fire escape cannot be used, this building's fire egress or life safety have been compromised. And so a portion of this building therefore cannot be occupied because it does not have adequate fire egress. It does not have adequate life safety. And as I said, the training goes through multiple examples. It pauses for questions. It takes questions. This training is designed to engage the learner in as tactile and hands-on a method as possible. And so with that, what I'll do is, let me pause here for a second, open it up and see, Jose, if there are any questions. And I've noticed some items going into the chat box, but I haven't had a chance to look at them. If we have any questions, anything you want me to address at this point, I'm happy to get into it.
So far, I don't see anything. I put a message there that I'll be monitoring the questions, but I don't see any questions at this point.
Okay, I appreciate that, Jose.
Sure.
So then continuing on, and again, this is the training and overview of the training, what it is that the training focuses on. We're still in the fundamental or the foundational modules. But this next one is module 4, and that is evaluating disaster damage. So at this point in the training, we started off with an introduction of the different types of disasters. Then we moved to how those types of disasters impact buildings, the forces, the manner in which those disasters cause damage to buildings. Then the previous module talked about when evaluating a building, we have to identify that the building has adequate structural safety and adequate fire egress. This module, module 4, takes all of that and starts bringing it together by providing examples of damage to the different types of structural systems caused by the various types of disasters. So you can see we're building as we're going so that the learners, so that the evaluators are able to then kind of build as they go through this. So by going into specifics on how each of the disasters will impact each of the structural systems and types of structural systems, we start with bearing walls. In fact, we discuss bearing walls, and then we go to frames, right? The columns and the beams. And then from there, we go into precast systems, and we'll talk about precast systems in a moment. So with bearing walls are designed to be loaded from above and from the sides. But when a bearing wall becomes overloaded from above, the bearing wall will bend, it will deform, it will develop horizontal cracking within the field of the wall. And so the training provides examples and it shows photographs of this type of damage to help the evaluator interpret and identify and interpret this type of damage. It also talks about when a bearing wall becomes overloaded in the field of the wall, such as you see here. This could possibly occur as a result of an extreme wind event, and certainly as a result of an earthquake. So when a bearing wall becomes overloaded in the field or the plane of the wall, then diagonal cracking will form. And so in an earthquake, as the building is moving back and forth, the bearing walls can and quite often do become overloaded in this direction, resulting in diagonal cracking forming in both directions, or an X type of cracking. And then the third method with which bearing walls can fail is when they are loaded perpendicular to the wall. They can result in bending or distortion or rotation of the wall. And just as we did with the first two types of damage, the training goes through examples of this type of damage, providing examples, photographs of this types of damage to help the evaluator identify it or diagnose this when doing their evaluations. This would be one type of an example. So in this particular case, what we're looking at is a bearing wall structure. This is a residential structure that was affected, and quite literally, the upper bearing walls and roof and structure were pushed or shoved off of the foundation. And so you can actually see down towards the bottom of this image, you can see just how much that front wall has been pushed back and the building has been pushed off of its foundation. So it's, using this as an example throughout the training, providing photographs, illustrations, animations, video footages to help the evaluator begin to diagnose these types of conditions, and then how to interpret these from structural safety and fire egress. The other thing, and this is an interesting point to make at this point in the presentation and both the training, is the point of this exercise is to look at the building immediately after a disaster so as to determine if that building can be occupied by the public, whether it's safe for the public to then occupy that building, whether there are limitations or it's just not safe for them to be in there at all. So the process is to go through this, make that determination, and put a placard on the building. But it's important that the evaluator recognize that that placard, the signage that we're going to put on this building, is not permanent. In fact, it's very temporary. What I mean by that is we are looking at this building immediately after a disaster. We are only making a determination regarding basic structural safety and basic fire egress. All of these buildings are going to be damaged. All of these buildings are going to require some method of repair, some extent of repair. We are not making that determination. We are merely making a rapid evaluation or a rapid determination of whether it's safe at this point in time for the public to go in and access that building. As time goes on, the building can become worse. The thresholds or the level to which we will let people re-enter buildings, that will return to normal. And so this placard or this signage that we put on these buildings is temporary. This slide is intended to illustrate in a building. This was after an earthquake. The building was damaged by the earthquake. In fact, if you look inside the red circle that just appeared on the slide, you can see how the ground floor has shifted and rotated. That shifting and rotation indicates that the column to beam and column to foundation connections have broken. And so we do not have adequate structural safety. So this building would be placarded with signage, a red placard or something that indicates to the public, this is unsafe to enter. But what's important to keep in mind is when we put that placard or that sign on this building saying this is unsafe to enter, that doesn't mean that the building must now be torn down. It just simply means it has dangers or it has conditions that the public cannot go in until repairs are made. So this building that you see in this slide here would receive a sign or a placard that says this building is unsafe. It does not have structural safety. The public needs to stay out of it. But this particular building did not need to be torn down. And so in this slide, what you are seeing is that same building, months later, has been lifted up. A new foundation is being constructed, and the building is being set back down onto this new foundation. So while immediately after the disaster or the earthquake, there was a sign or a placard put on this building that said that the public should not go in because it is unsafe, that does not mean that the building must be torn down. In this case, the building was repaired and returned to service. So that is a very important point for our evaluators, especially when they are in the community and they will be putting these placards or these signs on these buildings. It's very important for them to, one, understand that this sign does not mean it's being torn down or needs to be torn down, but that the evaluator, when placing that sign, if they encounter the public or they encounter the building owner, they can then communicate that to the building owner to say, this sign means that it's unsafe to enter. It does not mean it needs to be torn down. So just some of the subtleties or finer points that are part of this training that are imparted or shared with the attendees so that they have that understanding when doing the evaluations. So just like we did that with the bearing walls, we then go into the frame, which are the column and beam structures. So the column and beam structures, when they get loaded from above, you can see the blue arrows would indicate loading, and the load path, as we said previously, went from the slab to the beams, from the beams to the columns, and from the columns to the foundations. And so when this gets overloaded from above, it will cause the beams to sag or the columns to bend, as you can see in this graphic. The training.
Bill, we have a couple of questions that I want to address.
Yeah, please go ahead, Jose.
Yeah, before you continue, because I think it's related to what you're showing. From William Hudson, are you considering the inclusion of Type 4 construction?
So the training does not, so I appreciate that question. Thank you. The Type 4 construction, so we have various types of construction that relate to flammability, right? Or how protected it will be from fire, or what it's made of, so that we can determine the level of fire protection. This training and this exercise does not consider any compromises to that. What this training focuses on is far more fundamental. This training focuses on strict structural safety and fire egress. So that's what this training is. The evaluation of the type of construction and the impact the disaster has had on the type of construction and its fire rating, so to speak, that is at another level. That is done later in time by your design professionals.
Okay, yeah, he says that he was thinking about the reactions in heavy timber.
Okay, so with heavy timber, that would be a frame type of system. And so in a frame type of system, the evaluators, the attendees of the class, are trained how to identify the load path. So in a heavy timber system, it would be identifying the load path as a timber or a column and beam type of system. So you evaluate the columns, the beams, and the connections.
Okay. I got a comment from Jose Garcia. I'm going to translate it. It's in Spanish, but I'll translate it. It says, these examples apply to some structures. In the case of structures that are compromised due to extreme external environmental conditions, a different evaluation will be required. And that's just a comment, but I think that's, applicable too.
So, yeah, no, I appreciate that comment. And to build on that comment, going back to why we start with an explanation of the disasters and how they impact buildings, it's very important for the evaluator to know what was the disaster, and then from that, how that disaster impacts buildings, and then from there into what type of structural system. So yes, all of these are elements and components that the individual doing the evaluation must have an understanding of, so as to make the determination whether the structure has adequate structural safety and adequate fire egress. So I appreciate that comment.
Yeah, great. I think that's for now, but I want to mention that, I mean, a comment that, yes, you may see some examples of construction from the US, but this is applicable to all types of buildings in terms of damage, right?
Oh, absolutely. Absolutely. And you know what? We all build with steel, excuse me, concrete, reinforced concrete, timber, light gauge steel. It really doesn't matter what country you're in. This system is universal, and evaluating structural systems is universal. So it can, if, however, I've had an opportunity to work in the Caribbean, and I know in the Caribbean, timber construction is not that common. In the Caribbean, it's going to be more reinforced concrete frame type systems. So if you're doing training or deploying into that type of an area, this training course can be made very specific to that. So there's a lot of flexibility there. But I appreciate that comment, Jose.
Thank you, Bill. Yeah, thank you. For now.
I will then continue. And I'm just going to keep going. We did not plan on having any breaks, but I'm going to keep going, and hopefully I can have us done here on schedule. But again, as I said, the purpose of this presentation is to take you through and kind of let you look down on the training to get a sense of what it covers, how it's delivered, and as we talked about in those comments, how it can be modified or tailored to specific areas and methods of construction. In fact, this was a reinforced concrete building in Central America a number of years ago after an earthquake down there. But it just goes through and it's giving us in this presentation an opportunity to see some of the examples, photographs, video footages that are used throughout the training. So in this particular case, this is a reinforced concrete moment frame building affected by an earthquake. And in this slide, the training is highlighting the fact that when a frame structure fails, especially as a result of an earthquake, it's generally not the beams or the columns that fail, it's the connections. And so in this particular image, you can see it's the connections, or where the beams and the columns meet, that failed. And so the evaluator has an idea when going into an area that has been affected by, say, an earthquake. It identifies the building as being a frame building or column and beam. The evaluator then knows to really take a look at the connections to see if the connections have failed or not. And so this highlights the connection failure. This slide and the next slide are also examples of the concrete moment frame structure. In fact, in this one, this was in Southern California back in the 1990s, an earthquake down there. This was a concrete parking garage that was damaged by the earthquake. And so in this image, you can see the parking garage immediately after the earthquake. And inside those circles, you can see where it is the column to beam connections that have failed. Now, this slide also serves as a point of illustrating redundancy. And so, as I said earlier, part of evaluating a load path is also determining whether the building has redundancy, why it is still standing, if it is still standing. And so in this example, all of the beam to column connections had failed. but the building was still standing, and that was due to redundancy. The point here is just because a building remains standing after the disaster does not mean it is still safe to occupy. And so while this is what the building looked like after the initial earthquake, this next slide is what it looked like after the very first aftershock. So the earthquake caused the damage. The building remained standing because of redundancy, but it did not have adequate structural safety. And that point was illustrated when the aftershock occurred and the balance of the building collapsed, as you see in this slide here. And then, as I said, the training talks about bearing walls, it talks about frames, and then it gets into precast systems. And so with precast systems, it focuses on precast segmental systems as well as tilt wall systems. And it goes into them in a fair amount of detail. For the purposes of this presentation, I'm just going to show you just a few slides of the segmental example. But a precast segmental system is when the columns, beams, slabs, wall segments are precast offsite, brought to the site, and then assembled on site. And so the training goes through and provides examples, as you can see in this particular slide here. This was a parking garage. It was precast segmental, brought to the site and assembled. This damage that you're seeing here was actually the result of a flood event. In fact, the flood event here was roughly 4 meters deep of flooding. So what happened is the first elevated floor became submerged in the floodwaters. The floodwaters then lifted that floor off of its supports and dropped it to the ground. And that's what you're seeing in this image. The significance of this is that, and this is typical to all types of precast segmental systems, is that when that slab was lifted off of the supports and dropped to the ground, that slab was not only being supported by the columns, but that slab was also bracing the columns. And so the significance here is while the structure is still standing, the upper portion is very badly damaged, and the columns, which were designed to have been braced by that lower floor slab, are no longer braced and are now only capable of supporting half the load they were designed to support. So again, the training helps to educate the evaluator or the participant on how to read damaged buildings, how to evaluate the load paths, and how to determine when the building has been affected, its structural integrity has been affected or not. This is some video footage of a parking garage, parking facility. And one of the things that this training also talks about is progressive failures, continuation of collapse, and so forth. And so it also serves to reinforce that just because a building remains standing after a disaster does not mean it's safe to occupy. And so what you're going to see here when I launch this video footage, it's just a few seconds long, but what you will see is that as the segments and the sections begin to fall, other sections that were dependent upon it also begin to fall. So let me play that. So you can see in this particular example, it was like a domino effect. So the 2 slabs failed, then the next slab failed, and then it actually continued on through the structure. So just because a structure remains standing after a disaster does not mean it's safe to occupy. So that is that module. And, again, at the end of each module, there's examples, there's discussions, there's, making sure that the attendees are understanding these components, these foundational elements. The next module is post-disaster operations. And at any point here, Jose, feel free to jump in if there's any questions. So this next module, post-disaster operations, this is where we will take a break from the structural and the disaster stuff. This is the piece that will very much be modified to the jurisdiction. In other words, this is the piece that talks about disaster events and their phases. It talks about evaluator preparation. It talks about evaluator certifications. It talks about deployment of evaluators, and then finally demobilization of evaluators. It's inside of this module that any country-specific, region-specific rules, procedures, forms, authorities, all of those elements will be incorporated into this module. And this presentation is designed to be modified so as to make it region, country, or administratively adapted for use. It talks about the 4 phases of a disaster, the disaster being the event, as you see in the graphic. Immediately after the event, you go into a response phase. From the response phase, you go into recovery. From recovery, you go into mitigation. And from mitigation, you go into preparedness. Now, quite honestly, this training was designed to be part of preparedness, but it can absolutely be part of your response phase as well. Or in other words, if you have a disaster, if your staff is not fully trained, or you don't have staff and you will be bringing in outside assistance, this training can be delivered at that point in time so that everyone in the field doing the evaluations are doing them consistently and receiving the region and the jurisdictional specific training on site. It talks about basic evaluator preparation. So keep in mind, this training is being delivered to the evaluators or the individuals doing the evaluations. So this training covers how they prepare themselves. It talks about health and safety considerations. At my age, am I still capable of doing this? Or with whatever physical or health limitations I have, am I capable of doing this? Keep in mind, these evaluators are going to be in some extreme conditions, and it is their priority, their number one responsibility to look after their personal safety. So when that evaluator goes into that environment, that evaluator takes on the responsibility of looking after themselves. And so that is emphasized and communicated through preparedness. It also talks about some basic personal protective equipment that evaluators will need when going into the environment and performing these evaluations. It talks about clothing, articles of clothing, items that they can bring with them, items that they'll want to have on them, types of clothing, eye protection, head protection, boots, these types of things. It goes through lists. And the materials that are provided as part of this training will also have these key items, and in this particular case, lists of individual items that the evaluator can utilize when packing their bag, when going into these spaces, when going out the door to do these evaluations. It provides a list to refresh them and remind them of what they will need to take into those environments. It talks about evaluator certifications. You know, what is required to do this, what types of training are out there, and what types of certifications will they be provided as a result of this training. I can share with you that one of the things that are being developed by ICC on an international level, and certainly when taken into Central and South America and the Caribbean, is providing a certification card to indicate that an individual has been through this training and has an idea of how to do this, what is important, and someone that hopefully the jurisdiction can rely upon when doing these evaluations. It also talks about deployment, giving the evaluator some idea of what they're going to be in for in the environment. How long will they be there? What types of conditions? What conditions will they be sleeping in? You know, how will meals and accommodations be provided, and so forth. Very important to give them some idea ahead of time that, you know, that the evaluator is going into a disaster environment, and so they will be treated the same way that those living through the disaster will be treated as well. They will be sleeping in communal environments. They'll be provided with food on communal basis, right? It's very important to make sure that the evaluator understand that these will be challenging, perhaps austere conditions that they will be in. Also important to give them an idea on the duration of the deployments. Most deployments will be a minimum of 10 days to 2 weeks. Some deployments can be upwards of 3 weeks or so, especially if they're traveling internationally. But there will be a limit to the deployment. Individuals going into these environments, like any tool that we would use, they have a half-life, they have a shelf life. They will become exhausted at some point. And so after 2 weeks to 3 weeks, that resource becomes not as effective anymore. And so we want to rotate them out, pull them out, and bring in fresh resources or fresh individuals to do this. And then finally, evaluator demobilization. And so it's also educating them and providing an understanding that they're going into this environment to help that community by determining what structures are safe to enter, which ones are not safe to enter, and what kind of restrictions exist on those that people can enter. But it's also very, very important that the evaluator understand that the thresholds or the what buildings are safe to enter or not safe to enter, that is established by the locals, by the authority having jurisdiction in that environment. That is not established by the individual evaluator. I am not going to use my own criteria. I use the criteria that the local jurisdiction has established. That's a key point. Also, a key point is respecting the citizens in that community by protecting their privacy. So photographs, documentation, whatever is collected during that disaster is the property of the authority having jurisdiction. It is not something I'm going into to collect and to show the world, look what I did. It's not about that. It's about respecting the community. So that, as I said, that is the piece of this training that is very much customized to the region, the environment, and the political climate that we'll be working in. Now, this next piece, as we start to pull out of that, we go into the operational components. And so up to this point now, we've covered all of the foundational elements. Now we're going to move into the operational elements. And the operational elements are, how is it we do this? How is it that we actually carry this out and conduct this? And so at this point, I will be able to pick up the pace of the presentation because I'm not going to get into how it's actually executed. I'll share with you from this point forward how ICC is going to streamline and customize what is done in the U.S. for a much broader international deployment. So we'll start with disaster-related hazards. So the fifth module is all about disaster-related hazards. And this is going to be universal. This is going to be, it doesn't matter if it's happening inside the US, outside of the US, Central America, South America, Caribbean, it doesn't matter. All of us will face disaster-related hazards. And they come in several different categories. There's basic safety, there's environmental hazards, hazardous materials, the identification of hazards and the evaluation of them, and then finally the human factors. And we'll talk about that in just a second, but to mention some points on each of these. Basic safety, we talk about what is basic safety. I made the comment previously that the number one responsibility of the evaluator is their own personal safety. Yes, that evaluator is there to evaluate the buildings, but their number one responsibility is their own personal safety. Other basic safety includes the personal protective equipment that we talked about previously. It's highlighting the fact that when doing these evaluations, we're only going to do them during daylight hours for obvious reasons. We're going to do them as a team, meaning we will always have teams of two doing these evaluations. That's so that you have multiple eyes looking at that structure, but you also have individuals looking out for each other as well. It talks about making sure that the members out there doing these evaluations are identifiable, that residents can see them, can very rapidly determine that they are there to help and that they are not there for nefarious or malicious reasons. The training gets into how to survey and avoid hazardous situations, and then when it is safe to enter buildings. It moves into environmental hazards. And environmental hazards actually fall into a series of subcategories. So inside of environmental hazards, you have collapse hazards, secondary collapse. Each of these are illustrated, explained. There are practice examples that the individuals will utilize throughout the training. So in each of these categories, they're illustrated. And in the modules for this training, I will share with you that it's this particular module and this particular area that is the fastest changing. For example, collapse hazards, falling hazards, that's always going to be there. New are electrical hazards as photovoltaic systems come online, as energy storage systems come online, battery systems. As this gains wider use throughout the world, these systems are very hazardous systems, especially when they have been damaged in disaster events. And so as new hazards evolve, they're incorporated into this training so as to keep this training fresh. The training then goes into hazardous materials and routes of entry. So we want to educate the evaluator on what they should be mindful of, how to identify the threats, but we have to also accept that the evaluators, those of us operating in these disaster environments, are going to encounter hazardous materials. And so the training takes them through when you encounter hazardous materials, where you can encounter them, and then how they will impact you physically, how they cause harm to you. So where will we encounter them? Well, chances are we're going to encounter them everywhere we go, not just in commercial or industrial settings, but we're also going to encounter them in residential environments as well. Here on this slide here, you can see examples of possibly common materials used for cleaning homes and places of residence that in disaster environments and when spilled out, possibly mixed together, cause extreme hazards to individuals working in these environments. So it's helping to increase that awareness and make sure that it's front of mind on not only just evaluating the building, but being mindful of your environment, taking stock of what is around you that can cause harm to you. Also, educating the evaluator on how those materials enter our systems and cause harm to us. Any one of four methods, the four methods that you see on the slide here. So breathing it in, physical contact with it, ingesting it, and not so much that they would eat something, pick up something in a disaster environment and eat it, but if they're working in that environment and they're handling things, they're moving, just touching things, whatever they get on their hands, if not properly washed, will then wind up into their system. So that's when we talk about eating, that's what we're talking about. And then finally, any types of scratches, scrapes, or punctures, that also is a vehicle through which hazardous materials can enter our system. This particular model on disaster-related hazards then gets into how to identify those hazards, how to evaluate those hazards, how to avoid those hazards. The identification and evaluation, there's a process and a procedure that this training utilizes. The training goes through it in great detail with the evaluators. And then, as I said earlier, there are resource materials that are provided. ICC is in the process currently of looking at getting those converted into Spanish and various dialects so that they can be deployed and utilized and relied upon. And then finally, there is a section that talks about dealing with human factors, or basically educating the evaluator on how to, one, deal with survivors in a disaster environment, but two, how to be mindful of themselves. They are also going to be in this environment, and they are also going to be affected physically, possibly, or emotionally. And so there is a piece of this that goes through the how to deal with survivors and how to deal with those emotions, how to communicate with survivors, because the survivor has just experienced a very traumatic event, and the survivor needs to process that, and they will be in the process of processing what they've just experienced, but they're not going to be thinking clearly. And so there's techniques that the evaluators are trained on how to deal with those survivors. And then there is an element of being mindful. Being in that environment will affect us as evaluators. So being mindful of that as well. So that's the hazardous environment. That's the operational piece. The next 3 modules will go very quickly in this presentation and in with the training. But let me make a comment here on the next 3. The next 3 focus on how do you actually do the evaluation? What is the process, the form, the paperwork used on the evaluation? And so as the course was originally developed for use in the US, this portion, the actual forms and process, is very US centric. I will share with you that ICC has already committed to taking this process, simplifying it, and then translating it into Spanish and the various dialects for use outside of the US. And so this process that I'm going to show you is very US centric. It's based on US documents, some of which will not be translated into Spanish. So it's for that reason that ICC is now developing an international and Spanish version of these documents for use outside of the US.
Bill, you had a minute?
Yes, Jose, go ahead.
That's a very interesting, and yes, we are developing that, and it's actually in addition to English, but also Spanish for the international community. I do have a question here from Victoria. Could you briefly touch at any point of the training on the complementary role of drones in damage assessment, the strengths and limitations of drone versus field assessments, and emerging AI applications? I don't know if you're going to touch on that, but just want to put it out there so you have it.
No, thank you for that, Jose. And again, thank you. That's a fantastic question. And yes, that is something that is being incorporated into the training more and more. When do we use drones? How do we use drones? And what I will say to you is drones are drones can be very, very effective in the immediate after the disaster. So immediately after the disaster, drones are a very effective way of popping up and getting a very rapid bird's eye view of what just happened, what is the extent, what is the area, what does the terrain look like, what kind of debris are we facing. Drones are great at that. But drones become more and more limited in this training that we're talking about here, because in this training, it's designed to go building by building, structure by structure. And so the process, I didn't really get into it because that's part of what we would have covered in 1 or 2 of the previous modules. But the process is we walk up to a building, we identify the building, we capture whatever address or information, and then we do what's called an exterior 360, which is we physically walk the exterior of that building. And it's that process of physically walking the exterior of the building that we are looking at what is the type of structure, frame or bearing wall. Has it been affected by the disaster? If so, to what extent? What's the extent of the damage? Do I have basic structural safety? Do I have basic fire egress? And what type of environmental hazards? Do we have collapse hazards? Do we have spilled chemicals? What types of hazards do we have in this environment? And that's very much a teams of 2. The expression I've always used is ground pounding, that, boots on the ground pounding their way through. It's so you can use a drone, but it actually, on a building by building basis, it's actually faster to do it boots on the ground and walk your way around. Now, if I encounter a building that I cannot physically get all the way around, then yes, a drone would be a great way to do that building. So drones have a place in the disaster environment, absolutely. But there are appropriate and more appropriate, less appropriate uses of drones. So I hope I answered that question.
Yeah, I think so. I mean, we see more technology coming up anyway, so I'm sure that there will be ways to use it in the field.
Oh, absolutely, absolutely.
All right.
So continuing on, anyways, the two documents that you see on the screen here, these are referred to as the ATC 20 and the ATC 45. These two documents were developed in the 1980s here in the US by ATC for the state of California. And as Stephen was saying at the start of this presentation, much of what the US does is very US centric. It can be very state specific. And so here inside the US, the ATC was originally developed for the state of California and then is used throughout the US. What's unfortunate is the ATC has been asked and has declined to translate these documents into Spanish. So what ICC has stepped forward and is doing is we're going to take these documents, we're going to simplify them, we're going to combine them into a field manual, the elements of these and the process, simplify it, and then make that available in Spanish versions. So that is in the process. ICC is looking at all the aspects of it. And so the groundwork has been laid to do that. And so this training is already available. The supporting materials are being made available. The other piece, and I mentioned this previously when talking about tailoring this training and the materials to various regions or legal jurisdictions, are regulatory considerations. And so regulatory considerations can be absolutely incorporated into the training based on the region that they're to be deployed, and should be incorporated into the training and the deployment so that if you are bringing people in from outside of your region or your country, they will know what the rules are, right? What the regulatory considerations are, what they have the authority to do and not to do. So that is very much a component of this training and the materials. So as I said, the rest of this will go very quickly. I will simply acquaint you with what we are doing here in the States and what will be developed for implementation outside of the US. So inside of the States, we can do either a rapid assessment or a detailed assessment. But I will tell you that what is evolving in the US and what will be incorporated into what ICC creates for use outside of the US is the rapid and the detail are becoming fused together. When this process was originally conceived, the rapid was more or less just an immediate, what was the type of damage? Can we placard the building? Whereas the detailed was more thorough. Let's put a placard on the building to identify all of the hazards. So what I'm seeing through my years of doing this and teaching this and so forth is these two are being put together. And so there's going to be one assessment that is actually conducted. As it was originally envisioned, as I said, there was a rapid evaluation. The rapid evaluation was defined as an initial general evaluation of the damage and the safety, so as to quickly identify and post or placard the building. The evaluations were to be done by teams of 2, and the evaluation would take 10 to 30 minutes per building. And I will tell you that even the details, which you'll see in a second, can be done in that same time frame. So the detailed evaluation was originally intended to be a follow-up type of evaluation. But what we're seeing now is the process is the same, the forms are the same. It's really not that much more information. We're spending an extra few minutes per structure. So really what we're seeing is this is what we do. These can be done, the detailed evaluations can be done in as rapid a time frame as the rapid evaluations. The detailed evaluation is a careful visual examination of the building, its structural systems, and its fire egress to determine if there are any restrictions on the building. These evaluations are also done by teams of 2 and can take anywhere from 30 minutes. They can sometimes go up to 4 hours in length. That's not an efficient use of our resources if they're taking 4 hours. These are really intended to be rapid visual evaluations. The reason that the manual says 4 hours is because if you go inside the building, then that significantly slows you down and can take much more time. So those are the types of evaluations. The next module, and again, this is going to be US centric, but the next module gets into the actual forms and process. It goes through the actual forms themselves. And as I said, there is the ATC 20, which was put together to evaluate buildings after earthquakes. And then there's the ATC 45, which was put together to evaluate buildings after wind and flood. So the 45 that you see on the screen here was for wind and flood. The process is the same, regardless of the disaster, regardless of the manual that you're using or the forms that you're using. The process will always be the same. And the process is we begin with a rapid evaluation. The rapid evaluation is intended to identify structures that are obviously green, meaning okay to go back into and re-inhabit. Structures that are obviously red. Excuse me 1 second.
While you take a drinking break, one comment that somebody mentioned in the chat is that it's important for the approach path to do the evaluations to be safe, because depending on the height of the building, aftershocks could actually cause objects to fall and endanger the evaluator. So it's important to be safe when these guys are going out there and doing the evaluations of the building. So.
No, I appreciate that comment, and that absolutely true. Absolutely true. That's covered in the training when we get into collapse hazards, falling hazards, situational awareness, the initial size up. So yeah, that is a point. And then of course, continually throughout the training, emphasizing that the evaluators' number one responsibility is to their personal safety. So yes, that's a very valid comment.
Sure.
Getting back to the process. So it starts with the rapid. You want to identify the structures that are obviously okay for folks, for residents to reoccupy and re-inhabit. You want to, it was intended to identify those structures that were clearly completely destroyed, very unsafe for the public. Public shouldn't be in there for any reason. The yellow structures are structures that have been damaged, that contain limitations and hazards. And so really, this training is focused on educating individuals to identify those hazards. We can train anyone to identify a green structure and a red structure. This training is really focused on training folks on how to identify yellow structures, or yes, it's damaged. Yes, there are portions that are broken. And yes, there are portions that have restrictions. Don't go in, don't go on the third floor, whatever the restriction is. That's really what is at the heart of this training. Because remember, at the start of this presentation, I said the training is about identifying damaged structures, but also minimizing the displacement of our residents. People are going to go back into these buildings. We want to be able to identify the hazards and give them notice of those hazards. If it's desperately dangerous, we want to tell them that. Otherwise, we want to identify the hazards. And that's really what gets done in the detailed evaluation portion. And so there you can see where if we just go straight to the details, then we're going to have the information that we need. And then the third type of evaluation is not part of what we're doing here. The third type of evaluation is the engineering evaluation or the design professional evaluation. That is going to be done as part of the repair process. So that is where we'll go in and say, all right, how badly damaged is it? How badly damaged are the connections? What elements need to be repaired? That is not done under this. That is done as part of the repair process at a later date. The forms that were developed by the ATC that are used look like this. The rapid evaluation form is a one-page form. That's the one on the left. The detailed evaluation form is a two-page form, and that's the one on the right. So between these two forms, you can see they're almost, the layout, the boxes, the information that they're capturing is identical. And so as we move forward, the customization of these forms and the adaptation of these forms can easily be done and will be done. The organization of the field manuals, and this is if you choose to use the ATC manuals, but as I said, unfortunately, they are not going to be translated into Spanish. ATC has declined to do that. But if you choose to use these, this is how they're organized. It starts with Chapter 2 as an overview. Chapter 3 talks about the rapid evaluation process. Chapter 4 talks about the detailed evaluation process. And then chapters 5 through 12 focus on the type of structure. And so really the way these books are laid out is I identify what is the type of structure, what is the damage I'm looking at. I can then open the book, find an example, and then the book will give a recommended posting or red, yellow, green based on the type of damage. But here's the magic to the whole process. Once the evaluator has been properly trained and the evaluator understands how to evaluate load path, how to determine when a frame has been damaged or when a bearing wall has been damaged, when the evaluator can accurately identify structural safety and life safety, you don't need these manuals, right? We can develop and deliver this training so that we don't need these manuals. These manuals are if you question yourself, or if you're new to this, or We want to train people outside of the design professional community, right? That's where these manuals come in. And then finally, the placards. So with respect to the placards, I mentioned this previously. There are 3 placards that were developed by ATC, 3 placards that can very visually and rapidly communicate to residents which buildings are okay to enter, which ones are dangerous and unsafe, and which buildings contain hazards. And so that's the red, yellow, and green. So the green placard, which is what you see on the slide here, it is intended to communicate that the building may be damaged, right? There may be broken windows, broken floors, maybe we're losing some roof materials, but there are no apparent hazards and there are no restrictions on the use of the building. The building can go back into full use. If it's a residence, people can go back to living in there. If it's a place of business, business can be conducted in there. That is the purpose of the green. Green does not mean it's undamaged. Green simply means there's no restrictions on its use. The next category, the next placard, is the yellow placard. And so what the yellow placard is, yellow says it's intended to be caution. The building has hazards. The building has limitations. And there are restrictions on the use of the building. So for example, if it's a residential building, there might be a restriction, it cannot be occupied, meaning the residents can go in, they can collect their belongings, they can gather up their items, they can begin making repairs, but they cannot live there. That would be an example of restrictions. Another example of restrictions would be if electrical distribution within the structure has been compromised. The restriction may be, do not energize this building until electrical repairs are made. So that's the purpose of the yellow placards, to communicate to the public that there are restrictions on the use of the building. The building is damaged, there are hazards, and there are restrictions. The third category, the third placard, is this one, the red placard. This placard is intended to communicate to the public that the building is unsafe and cannot and should not be occupied. It contains extreme hazards and cannot be or should not be occupied. And I'm coming up on the end. 1 or 2 comments on the placarding, and then I'll open it up. Jose, if we have any questions or if anybody has questions, you can start thinking of them now, putting them into the chat box. But to wrap up, the training wraps up and this presentation will wrap up with just a comment or 2 on the placards. And that is that the training gets into and reinforces that when we're doing these evaluations and placing these placards, we want to educate the public on the hazards. We want to educate the public on any restrictions, but we don't want to be overly conservative, right? Just because a building has damage doesn't mean we have to keep the public out. And let's be honest, people are going to go back into these buildings no matter what placard we put on them. So this is more about identifying the hazards and educating the public, not just about identifying damage and putting a red placard on the building. And that's really what is at the heart of this training. So there are 2 more modules left. I'm just going to flip through some slides for you. The operational piece, the rapid evaluations, whether it's earthquake, wind event, what we do at this module, so we've educated the evaluators on everything that they need to know up to this point, how to place the placards and so forth. The training then goes into practice examples. And so we begin practicing this process, the evaluation and the placarding with the students in the class, making sure that they're trained up and that they capture that they can demonstrate an understanding of the process. As I've been emphasizing, it all comes down to structural safety, life safety, identifying hazards, and respecting the locals, the community, and the authority having jurisdiction. That was on the earthquake. We do the same thing with wind examples. We can do this with flood examples. We have scores, tens and tens of examples, practice cases that we use in the training. All while emphasizing that by allowing residents to remain in their homes and businesses until repairs can be made, services restored, will minimize the need for temporary shelter and will help accelerate the recovery process. The detailed evaluations, again, this is based on the US-centric process. Same thing. We go through practice examples. This one is a earthquake example. And then this would be a flood example that the class goes through. That particular case, that was coastal flooding. That's a beach area. You can see how the ground floor was washed out. And so it's, again, emphasizing, practicing, reinforcing this process, making sure that the attendees truly understand what they're doing. And then finally, wrapping up with the placarding, we talked about the 3 different placards that we will be posting. And then we go through the rules. And these are more or less universal rules. They absolutely can be adapted. But the universal rules are that each building structure receives one designation. In other words, one building is either red, that building is either green, or it's yellow. We're not going to do different colored placards on different sides of that building. Another universal rule is that building and its classification or its red, yellow, or green status can and often change based on aftershocks, additional weather events, anything of that nature. When we are doing a yellow placard and we are putting restrictions, or green or red placard, we're putting notes. You want to make sure, and the individuals are being trained to keep those notes concise and short. Finally, the posting procedures. On a residential structure, one placard placed next to the front door or the primary means of ingress. Doesn't matter how they go out, it's the primary point of ingress. Because remember, that placard is being put there for the public. And so residents, one placard next to the front door or the primary point of ingress. In a commercial building, a placard next to every point of public ingress. So if I have a commercial building with 4 entrances, I will put up 4 signs, one next to each of the 4 entrances. And so that, my friends, is the training. It was, something to sit through. I recognize that. I appreciate you sitting through it. But and please keep in mind, I went through that very quickly and at a very high level. The training, as I said at the start, is between 6 and 8 hours to deliver. It's very practice oriented, very example heavy, with the intent of making sure that individuals are properly trained before going out the door to do this. So with that, Jose, I'm going to stop sharing, open it up, and see if there's any questions or anything else.
Well, thank you, Bill. That was amazing. I know the training is very extensive, but I actually took it I took the 2-day class, you know, and I was actually certified on that as a building official. First of all, I want to apologize because I didn't introduce you properly.
No,
But
no, no.
I know your bio was in the presentation, but Bill has over 40 years of experience in this field, engineer, structural engineer, and he's very passionate about this work. I got one question that I was going to answer based on my experience, but I'm going to let you answer that. And it's actually, if the building has a 1% damage, do I classify it as uninhabitable? That's interesting because I don't know if we actually evaluate by percentage. I mean, how do you look at the situation?
Well, you make a good point, Jose. We don't really look at it by percentage. Hopefully that when someone goes through this class, they don't think in terms of percentages or dollars or anything of that nature. Hopefully when they come through this class, it has been tattooed on them. It's all about structural safety and fire egress. And so if we have structural safety and we have fire egress, we can let people go in that building.
Exactly.
And so we really want people to stay in their buildings. So really what we're doing is we're looking for reasons that they restrictions, right? We're focused on restrictions as opposed to 1% or 10%. So
excellent. Yeah, that was going to be my answer. You know, it's basically based on the damage and how safe it is to actually enter or get out of the structure. At the end of the day, we want the community to be restored as quickly as possible, and that's the main goal in this. Few comments that I want to address in the chat. I know that this training is being heavily concentrated in the US, but disasters are everywhere. I mean, this is something that is global. So can we expand a little bit about what ICC is going to be doing and our commitment to actually, you know, do this for the communities? And also, I want to touch base on how important it is to be prepared before the disaster. Because, you know, sometimes we just wait to that moment and then we want to be ready. But how important it is to have your staff prepared before this happens. And it's going to happen. The question is not, you know, if it's going to happen, it's when it's going to happen. So, I mean, that's, if you want to expand on that, that'd be great. And I don't know if Judy or Stephen have any comments on that too.
Yeah, so I was actually going to jump in there and say, how about Judy, if you would talk about ICC's commitment, what we're going to do, and some of the things that we've talked about developing, and then if we can kick it to Stephen and let him address the, being prepared beforehand, because it's his passion and his desire that kind of got us to this point.
Sure. Thank you. And I just want to echo Jose's thanks to you, William, Bill, for offering this great overview. I mean, I think this was never intended to be the training. It was designed to be an introduction to what the training is. And also, the intent was to identify interest. And, we recognize, and Bill has prepared this training, and he's pointed out many points during the training where, it needs to be localized. We want to insert local rules. We want to insert local pictures. We want to insert, local culture, so that it's very relevant to the audience. And the intent is to customize this, not just one Spanish version, right? But a version that will work. A different version that will work in each country, each jurisdiction. Maybe they can be regionalized. We're very flexible on how we do this, but we want jurisdictions around the world to be able to leverage this tool that we've developed. It's ready, it's off the shelf, it just needs to be customized. And that's sort of ICC's philosophy with developing model codes, model tools that are much easier to customize than starting from scratch. And so we have the training modules available. The real key component that's missing is the field guide that needs to be in the local language. And so we are moving ahead with developing a guide that can be localized or translated for use internationally. While that is in development, we are interested if there are people on this call or if you or on this webinar, if people who are watching a recording that think, yes, we need this in our country, we want to help to customize it. ICC does not have, people from around the world in our employee base to do all of the customization. We want to work with partners who have an interest in their region, in their country, in their jurisdiction to provide this training. And, again, the idea is not for ICC employees to travel around the world offering the training. It is to train people on this program and empower them to have a local version of the training that can be offered locally. So it's a local for local solution, training the trainers and making sure that we can get these resources available along with the field guides that we'll be producing to people around the world. As Jose said, in advance of disasters, we know that disasters will happen. And if you don't live in a seismic area, that's okay. You're probably going to have to worry about flooding or hurricanes, high wind events. There's no place in the world that is immune from disasters. So this training is useful for everyone. Advanced preparation is critical, and having the resources available locally and in a contextually appropriate format is also really critical. So we're committed to doing all of that. It's not all ready yet. So it's in process. And if there are groups that are interested in, again, partnering with us to create localized solutions, please reach out to Jose or me. Our contact information is in the chat, and maybe Jose, you can just paste that note again in English and Spanish so that it's at the bottom of the chat so people can see it. And then I'll turn it over to Stephen.
Sure. I'll just mention again, as a private practicing architect in the United States and Ecuador, we're all in this together. We're all engineers, architects, professionals trying to do the best thing for the people, for our communities and people we work with. Myself as a professional architect, I joined a membership, joined ICC to collaborate, and as a member picked up the phone and said, "Hey, we've got a problem. In particular, from my case, we've got a problem in Ecuador, and how do we share from this information?" The great part is we don't have to reinvent the wheel. The best way for us to tropicalizar this is to look at what's being done at different places and then adapt and adopt that to our local environment. This is just the train the trainer program about inspectors. This is just the inspection program. There's a whole nother module about how to prepare and organize all of those inspectors that are coming to an incident. And ICC and William can really help us. Like, how do you organize? Where do those people come from? Where do you keep the lists? How many days do you deploy? And every country, every municipality is all going to be slightly different because all of us have a different reality. But I think the exciting part here is that William and Judy and Jose are open to collaborate with all of us. So feel free to reach out to Jose. He'll get us all together. And depending on the size of the reaction, we might even have some forums of us getting together as a group and discussing what's most important and what we need to do to attack this. This is not about a business. This is about professionals helping other professionals together to get the resources we need for our community.
Thank you, Stephen, and I agree with that. I think that from ICC point of view, I mean, we have been working with different organizations in Latin America, the Caribbean, and we are fully committed to partner with them to actually provide this training. The recent events in Venezuela, is tremendous what we're seeing there. Somebody commented that we need architects and engineers in Venezuela to actually get that training. In many times, they are the ones doing these field evaluations, but it's important with the amount of structures that are damaged to evaluate these and really, provide that safety net to the community. So that's the key on this one. My personal experience, I took this training the full day, and even in the city of Austin, we experienced flooding events. and we had to quickly evaluate the houses. And I mean, in many cases, there was no way that people could actually go back to it. So it is important, and I know that as we see more and more disasters around the region, that's what we need to be prepared for. Any final comments? I don't see any other questions. I see a lot of people just thanking us for the webinar. I've been getting some emails, so that's good. So yeah, the contact is there for Judy and myself. If you have any questions, and if you're interested in joining, and partnering with us on this one, but I know we're going to be working pretty hard to get this out as soon as possible. We cannot wait for the next earthquake or the next hurricane to actually hit us and be unprepared. So,
Jose, can I just add
yes.
one little bit? And that is that in preparation for this course, one of the reasons that we decided to do this is that if you look on some websites in Venezuela, there's some phenomenal engineers and architects that put together I think is a miracle of you can send in photographs of your building and they'll use these same manuals to review your building and give you an assessment of what the building's like. An extraordinary effort. I mean, this is Latin America. We do miracles. I think what we're talking about here is about really institutionalizing this, making this a lot more accessible for everyone, and giving everyone the tools necessary to get this done, and ultimately creating just really an army of architects and engineers that are qualified and able to do inspections and after disasters and earthquakes, just to help our communities, to help our families.
Thank you. And I finally want to thank the team of interpreters that provided the translation in Spanish. I mean, they did a great job. I was actually listening to, going back and forward. And thank you for that. And anybody that joined, I mean, we're here to help you out. So if we don't have any further comments, Judy, Bill, we're good?
Very good. Thank you.
Thanks, everyone.
Thank you very much. Have a good day.